How's it going, ladies and gentlemen? It is Mr. Donahue here again. This time we're going to take a look at 2.89 topic, nomenclature, and we're basically going to be learning the language of chemists. All right, so our objectives will to become familiar with the basics of chemical nomenclature, basically how we name chemicals, including naming ionic compounds and simple organic compounds. Okay, so let's talk about ionics first. Naming ionic compounds like NaCl, what's the name going to be? Well, there's a general format of there's always the first name, and then there's a Roman numeral if you need it, and then there's a last name. All right, so the first name is going to be the name of the cation or the positively charged ion, and then the Roman numeral is going to be for the charge of the cation. If there's more than one possible charge for that cation, like if it's a transition metal, then we need to say which state is it, which charge ion are we using, and then the last name is just going to be the name of the anion. So let's take a look at those first names. If it's a cation of a metal, then the first name is simply the name of that metal. So if it was like NaCl, well, the first name is just going to be sodium because that's what it is, right? If it was Zn, it'd be zinc, so on and so forth. If the metal has more than one possible charge, like it's a transition metal like iron or something, then you need a Roman numeral equal to the charge. So the Roman numeral is the charge. Okay, so if we had Fe plus 2, then it'd be iron and Roman numeral 2, because that's the charge, plus 2. If it was iron 3, then it'd be iron with a Roman numeral 3. So it's just the Roman numeral is the charge, okay? So continue. Cations formed from nonmetals have a name that ends in ion. So, for example, if the cation's NH4, well, that's ammonium, right? If we had H3O plus, that's hydronium. So if they're nonmetals as their cation, it'll probably end in ion instead of just the element's name. The last name, well, if it's monatomic or monoatomic, meaning that we have one atom, we've replaced the ending with "ide." So if there's only one element, you change the suffix to "ide." So for example, if it was NaCl, well, the sodium is the first name, so it's just sodium, and then the chlorine becomes chloride. So that's the only thing you really need to do. So if we had CaF2, well, that's going to be calcium fluoride. Notice fluorine becomes ide. If it's a polyatomic ion, again, poly means many, so many atom ions. They have names that end in ate or ite. So I'll show you some examples, like NO3 minus. Well, notice that this is made up of many atoms. The NO3 has 4 atoms, so it's polyatomic, and it's an ion because it has a charge right here. Is a -1 charge, so it's a polyatomic ion, and its name is nitrate. Notice the ate ending. So polyatomic ions. The ate ending is used for the most common oxyanion. So what the heck's an oxyanion? Well, the oxy is telling you that it's oxygen, and that the anion is telling you that it has a negative charge. So if we take a look, chlorate would be ClO3 minus. Note how there's the oxygen there. So that's an oxyanion. It's a negatively charged anion, or negatively charged, thing that has oxygen in it. So chlorate would be the most common oxyanion. If it's an ite, it's the same charge, but it has one less oxygen. So for example, ClO2 minus would be chlorite. Notice there's one less oxygen, and the charge is the same. So the ate becomes the ite if there's one less oxygen. And you put a per in front of the name that indicates there's one more oxygen than the 8. So if I had chlorate, well, chlorate has ClO3. Well, if I had ClO4, then what would the name be? It'd be perchlorate. You put per in front of it. And if you had hypo in front of an ite ending, it indicates that there's one oxygen less than the ite ending. So if I had chlorite, well, all right, what would it be if I had one less oxygen? ClO. With a minus, and that would be called hypochlorite. Okay, so it's probably confusing at this point, but just bear with me, okay? So what I'm gonna tell you guys you should do is you should memorize all the ATES, the eights. All right, so here are the eights. We have NO3 minus, which is nitrate. We have ClO3, which is chlorate. We have CO3, which is carbonate. We have CrO4 minus 2, which is going to be the chromate. We have SO4 minus 2, which is sulfate. And we have PO4 minus 3, which is phosphate. All right? So memorize those. And then you can figure out the rest of them just by following the pattern. If it has per, you have plus 1 oxygen. 8 is just whatever you memorized, right? Ite means you have minus 1 oxygen, and hypo means you have minus 2 oxygens from the 8. So let's check it out, okay? So if I had NO4 minus, that would be pernitrate, right? And if I had ClO4 minus, that's perchlorate. If I had CO4 minus 2, that would be percarbonate. If I had CrO4 or O5 rather minus 2, that would be perchromate. If I had SO5 minus 2, that would be persulfate. And if I had PO5 minus 3, that'd be perphosphate. Some of these you won't really see like ever. So, but I'm just showing you all of them so that you can, see the pattern. And if it was an ite ending, you have one less one. So I'm going to erase these names real quick. All right, so what would nitrite be? Nitrite would be NO2 minus, so that'd be nitrite. Chlorite would be ClO2 minus. Carbonite would be CO2 minus 2. Chromite would be CrO3 minus 2. Sulfite would be SO3 minus 2. And phosphite would be PO3 minus 3. What if I had hyponitrite? Hyponitrite, so hyponitrite would just be NO minus. Hypochlorate would be the ClO1 minus, right? Hypocarbonite, there's the pattern there, okay? So just notice the pattern. So if you have an H in front of an oxyanion, you add the word hydrogen to it. So for example, we have CO3, that is going to be carbonate, and we threw a hydrogen in front of it, so we're going to call it hydrogen carbonate, okay? If you had H2PO4 minus, that would be dihydrogen phosphate because we got 2 hydrogens. So we throw hydrogen and we throw a di in front of that to tell us we got 2 hydrogens, and that's dihydrogen phosphate. All right. Note the H is really an H plus, so the negative charge also becomes less negative for each H plus added. Right. The carbonate is CO3 minus 2. If I add an H plus to the front, now the overall charge is now just minus 1. And that's how we get hydrogen carbonate. All right, practice naming ionic compounds. Let's try. All right, so why don't you guys try naming these, pausing the video, naming them, and then checking. Okay, so pause. I'll wait. All right, welcome back. So we got NaCl. Well, the first name is going to be the metal, sodium. It's not a transition metal, so it don't need a Roman numeral. It can only be +1 charge, and the chlorine becomes chloride. All right, so again, we got Al2O3. So I got aluminum. Aluminum can only be +3, so I don't need a Roman numeral. And the oxygen is going to become oxide. All right, copper is a transition metal with more than one possible charge. And NO3 is nitrate. So I know the last name is going to be nitrate. And I got to think, well, what is the charge of this copper? Well, NO3 is going to be -1, so the copper must be +1. So I'm going to have copper. In parentheses, Roman numeral 1. So that's copper nitrate. Now here I got 2 polyatomic ions. I got NH4, which is ammonium. And I have ClO4 minus, which is perchlorate, right? So that's going to be ammonium perchlorate. And that's how you name those ionic compounds. Not so bad. All right, naming acids can be a little bit obnoxious, but it's got a system to it. All right, so naming acids is a little different. If the H is written first, that's how you know you have an acid. It's saying that the H will ionize into H+. That's an acid, right? So why do we put H in front of these? Because it's an acid. If H goes first, you have an acid, and you got to name it like an acid. So HCl, H2SO4, those are acids because you had the hydrogen written first. Right? NH3 is not an acid because the hydrogen is not written first. It's written second. So NH3 is not going to be an acid. All right, so just add H and another element. If it's, if it's just H and another element like HCl or HBr, what you're going to do is you're going to follow this pattern. It's going to be hydro, and then whatever that element is, and then end it in ic, and then acid. So for example, HCl would be hydrochloric because it's chlorine, but you change it to ic acid. HCl, hydrochloric acid. HF, hydrofluoric acid. HBr, hydrobromic acid. So that's how you're going to do it if it's just two elements. If it's just hydrogen and something else, you're going to have hydro, whatever the element is, ending in ic, and then acid. Now, if your acid is made with a polyatomic ion that ends in ite, you're going to change it to us acid. So, like, if you got, I remember like this, itis. You get the itis. If it's got the ite ending, you change it to us. Okay? So if I had HClO2, well, it was chlorite, right? The ClO2 is chlorite. So if it's an acid, because it's got a hydrogen in front, you just change the ite to an us ending and add the word acid. So that'd be chlorous acid. Right? If it has an ate ending, you change it to ic acid. I remember like it ate something gross, you go ic. So ate ic. So for example, we have nitrate, right? NO3 is nitrate. You change the ate ending to an ic and you get nitric acid. That's how you name those acids. So let's practice naming some of them. All right, so same deal. Pause the video, try naming them, unpause the video, see how you did. All right, so here we got just two elements, so it's hydrogen and bromine. I know it's an acid because the hydrogen's written first, so I'm going to put hydrobromic acid. There you go. So the hydro is telling me it's just hydrogen and bromine, ic acid, the ending. So ClO4 is going to be the perchlorate. So what do I do with the ate ending if it's an acid because it's got that hydrogen first? Well, I'm going to change the ate to ic, so it's going to be perchloric acid. That's all. Now SO4 is sulfate. So what do I do with the ate ending? I change it to ic, so it's going to be you could put sulfic, but what you're probably going to see more often because it just kind of sounds better is going to be sulfuric acid. All right, and then the last one, we got ClO. That's it. So what is that? That's going to be, that's hypochlorite. So what do I do with the ite ending? I change it to us. So that will be hypochlorous acid. Okay? So, yeah, that's naming acids. All right, binary molecular compounds. What does that even mean? Binary means that you just got two elements. Molecular means that you're making molecular compounds, that they're only nonmetals. And compounds mean you got more than one element there, right? So it's made of only two different elements, and both of them are nonmetals. And that makes it molecular and not ionic, right? So you're going to get molecules and not ionic compounds. Example would be like CO2, H2O, CH4, PCl5. All those are just two elements bonded together. So naming these is, I think, probably pretty easy, pretty straightforward. So the element that's furthest to the left is written first, usually, on the periodic table. Yeah, to the left on the periodic table is generally written first. Oxygen is always written last, except when it's with fluorine. ClO4 would be an example. If both elements are in the same group, then the bottom element is given first, because most of the time it's the less electronegative element. So you're going to put the thing that's going to be like more positive on the left side, just like with ionic compounds, you put the cation first. With these molecular compounds, you're going to put the less electronegative thing first because it's going to become more positive than the rest of it. So the second element has its ending changed to "ide." So, and we also use Greek prefixes. I mean, you know, except mono. Mono is never given for the first element because it's like, yeah, duh, there's one of them. There's at least one of them. You just said the name. You don't have to say mono something for the first element. All right. If the prefix ends in an A or an O, the element begins with a vowel, then the A or O typically gets dropped. So, like, for example, if you wanted to say mono, if you wanted to say one oxygen, if you had CO, the name would be carbon. And then you got to say how many you have of the second element. So you would say monoxide. So originally you would have something to be like mono and then oxide, and then that's just weird. Monoxide. You're gonna drop it because that element starts with a vowel. All right. So yeah, Greek prefixes. You're gonna need to know some of these. Here they are. Know them, love them. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are them in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So practice naming some binary molecular compounds. Pause the video and then try naming them. Unpause it. You know the deal. Okay, well, welcome back. So I have H2O. So how do I say two hydrogens? Well, di for two, hydrogen, monoxide. Mon for one oxygen, oxide for it being oxygen. And if you really want to mess with people, you can even YouTube it and check dihydrogen monoxide. You'll see like public service announcements saying how dangerous it is. It's kind of funny. You can trick people into banning water. I think it's hilarious. All right, Cl2O. Well, how do I say I have two chlorines? Dichlorine monoxide. P4S10. Well, how do I say four phosphoruses? Tetraphos. I can't spell. And 10 sulfurs. Decasulfur. NO, you'd have nitrogen monoxide. CO, you'd have carbon monoxide. N2S, you'd have dinitrogen monosulfide. N2O3, you'd have, again, dinitrogen trioxide, because you have three oxygens. And pH3, you'd have phosphorus trihydride. There you go. All right, so naming some simple organics. We're almost done here. Organic compounds contain carbon and hydrogen, the simplest of which are hydrocarbons, literally hydrogen and carbon. So their general naming is you have a prefix, a base, and a suffix. And the prefix is going to tell you about any substituent groups, anything on that carbon chain other than hydrogen that kind of makes it special. The base is going to tell you what the parent molecule is, basically how many carbons are there in the carbon chain. And the suffix is going to tell you what kind of functional groups exist in that compound. So ane is going to tell you have only single bonds because they're an alkane. If it ends in ene, there's a double bond somewhere, so because it's an alkene. And if it ends in ine, there's a triple bond somewhere because it's an alkyne. If there's an ol, it's an alcohol group. You can even see like the ol ending is in the word alcohol. So the base, how many carbons? So you need to memorize some other stuff. Meth tells you that there's one carbon. Eth2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non is 9, and dec is 10. So if I had methane, well, that tells me that I have one carbon and it's bonded with just hydrogens on there, right? Oh, forgot the E up there. So yeah, so that's telling you how many carbons there. So if I had 2-methyl butane, well, the methyl group is telling me that there's a single carbon group that's where a hydrogen should be, and the butane's telling me but 4 carbons, ane single bond. So I'm going to end up with something that looks like this: 4 single bonded carbons, and they would normally have just hydrogen all over them, which I'm not going to bother drawing the H's, but it's saying methyl, there's a CH3 group somewhere, and it's on the second carbon. So 1, 2, there's a carbon and a methyl group here instead of a hydrogen. So that's 2-methyl butane. Or what if I had 2,2-dichloropentane? Let's break it down. Pent is telling me I got 5 carbons. Ane tells me that there's single bonds. and I can't spell, there you go. Dichloro tells me that there's 2 Cl's, and these numbers are telling me what carbon that they're on. So let me draw it out. Pentane, I got 5 carbons. They should have hydrogens all over them, normally. And I'm not going to draw the H's. Single bonds, because it's an alkane, it's an ane ending. And the dichloro tells me there's 2 Cl's, and the 2's, 2, 2 tells me that they're both on the second carbon. So 1, 2, they're both right here. So I got a chlorine here and a chlorine there. And that is 2,2-dichloropentane. All right. So I don't expect you guys to be an expert in naming organics at all yet. Later in the year, we'll be doing that kind of stuff. Just understand the structure to the naming so that you're not completely in the dark about what these compounds are. All right, so to summarize, what are ionic compounds and how do you name them? And what are some common polyatomic ions that you will need to know rote, meaning, off the top of your head, memorize? And what are binary molecular compounds and how do you name them? And how do you name organic compounds? How are organic compounds named? What's that pattern? So that's everything. I hope you found it helpful. I'll see you in class. Okay, bye.